Hey guys, we're going to take a look at section 2.1. As we're doing these videos, please take notes, listen to what I have to say. Sometimes they give you little shortcuts, but of course you can always pause it and look at the actual writing on the slide. So 2.1 deals with our learning objective on analyzing relations and functions. We're going to take a look at the next slide in a little bit, which is the vocabulary. With the vocabulary, we have an independent variable, which is the x variable, and that's our input variable. The dependent variable is normally our y variable, and that's our output variable. The output, the answer, depends on the input variable. Function is notated as f of x, and that's a function notation. Vertical line test helps us determine if a line of a graph is a function. The next one is discrete relation. In a discrete relation, we're going to look at dots. They are not connected. Continuous relation is a line where they're all connected. Then we have a one-to-one function. In a one-to-one function, each domain is exactly connected to one range. And that's the one-to-one function. The onto function is where the range has two inputs, two different inputs, I should say. The one-to-one and onto function, every domain has exactly one range. So if there's, say, in this case, 4 elements in the domain, then there's exactly 4 different elements in the range. When it's that, it's called one-to-one and onto function. With a vertical line test, which is what's going to determine a function, if you look at the one on the left indicates that my dashed line, which represents the vertical line, is cutting it in one spot, so it's a function. On the right, it's cutting it in 2 spots, my dashed line, which indicates my vertical line test. I usually use a pencil or just, draw a mental up and down line. If it touches at 2 spots or more than 2, it doesn't work. The domain and range, when finding the domain and range, the domain are all the x values from the smallest value to the largest value. You can make it as a table with the domains, or you can just write it as a list. And you can kind of look at the answer and check how they did it. No repeats. And if you want to see if it's a relation, I suggest you graph it. In this case, you plot the points, and the line do not touch, the vertical line doesn't touch it at more than one spot. So go ahead and write down your domain list, your range list, and see if it's a function by using your vertical line test. If you want to pause it to give yourself more time, go for it. Okay, so let's go ahead and check your progress and how you did. So hopefully you had those domains and ranges. Sorry about the fuzziness there. And because my line test only went in one spot for every single point, if I drew up and down line, it only touched my blue dots at one spot. So it is a function. Here we have an example on fuel efficiency based on the SUV's year that it was made. So varying years is my input, fuel efficiency is my output. And the best way to decide if this is a function is to actually graph it. And in your graphing, make sure you have the year as your x coordinate and the fuel efficiency as your y coordinates. Make sure you go by certain tick marks. As you can see on the left side, we went by 0.4s if I'm not mistaken. And then we plotted the points. In knowing if it's a function, you draw a vertical line test, or you slide your pencil from left to right. And no blue dot touches my vertical line in more than one spot, so it is a function. Because the dots are not connected, they are discrete. Now you try it. Once again, if you need to pause it, pause the screen. But go ahead and take these ages of, is it one baby? I guess it is one baby. And then the weight, and see if it is a function. Okay, let's see how you did. Once again, I do apologize for the fuzziness, but age is your input, weight is your output. When I draw a vertical, when I use my pencil as a vertical line, go through from left to right, no dot is touching my vertical line in more than one spot, so it is a function. So we're graphing a relation, another type of relation. So instead of ordered pairs, now we have a graph of y equals 3x minus 1. In this particular case, it is linear because the exponent of the x variable is 1, understood. So it's a line. Because it is a line and it's continuous and it's not stopping, it is automatically continuous. And that's the easy part. Now let's look at the domain. The domain are all the x values. So to graph it, you would have made a table. You can pick any values you want. In this particular case, we picked -1, 0, 1, and 2. Plugged it into the equation and ended up with these corresponding y values of -4, -1, 2, and 5. Plotted them. Once again, notice it was continuous. And list all the domains, list all the ranges as we've done before in order. So it is a one-to-one function since every single x value corresponds to every single y value. They're the same amount on both sides for domain and range, so it's also onto, so it's both. And make sure you write the domains in a list or use your table, and since no repeats, we're good to go. The last thing we're going to talk about is a function. Function, you're just replacing the value inside the f of x. So in this case, f of -2. We're replacing -2 into the equation, and we are working just the right side to get our answer. In this particular case, -2 cubed, -2 times -2 times -2 is -8 minus 3, ends up being an answer of -11, and you would write your answer according to what the screen mentions. Our next example is to substitute. Hopefully you notice it's 2t. If not, I have it there on the slide for you. So 2t cubed minus 3. When I work it out PEMDAS, I end up with 8t cubed minus 3. And so the final answer is f of 2t, which is my input, gives me an output of 8t cubed minus 3. Input, output, domain, range. So you try this. Plug in 3a into the x slot, work out the right side only, and see what answer you get. Voila! Hopefully you end up with 9a squared plus 5, because 3a times 3a is 9a squared plus 5, and that is your final answer. So input is 3a, output is 9a squared plus 5. We'll see you in class tomorrow. Make sure you understand. Bring your notes. If not, ask questions if you do not understand.